Hi guys, it's Glenn with Expulsion Science, and today we're gonna learn about endothermic processes by making and freezing our own ice cream. We need 4 ounces of milk, 4 ounces of heavy whipping cream, a 1/4 teaspoon of vanilla extract, 4 teaspoons of sugar, lots and lots of ice, a quart-sized Ziploc bag. Also, if you'd like, some food coloring to add some color to your ice cream. We don't have rock salt, but we have some iodized salt, and it'll do just the same as the rock salt will. The first part is simple because it involves getting all the ice cream ingredients together. So I'm starting out by adding my half and half to the quart-sized bag. So there's the milk, 4 ounces of heavy cream. Simple enough. Believe it or not, this is gonna be some delicious ice cream. Now for the 1/4 teaspoons of vanilla extract and the 4 teaspoons of sugar. And I'm gonna add some yellow food coloring here. Now seal it up. We're gonna put our bag full of ice cream ingredients inside of the gallon bag, and we're gonna add our ice. So let's go ahead and add some now. We're gonna add as much ice as we can. Now, we're gonna take our salt, or you can use rock salt, and we're gonna pour quite a bit in here. Just be generous with it. We're gonna toss it and turn it until we make ice cream. Whew, that's cold on your hands. Okay, so here's where the science happened. When the salt hits the ice, it really wants the ice to melt. But in order for the ice to melt, it has to borrow heat from somewhere else. The easiest place is the ice cream mixture that it's in contact with. So the ice steals the heat from the ice cream, which in turn cools off the ice cream to the point of freezing it. This is called an endothermic process, which simply means in order for a reaction to occur, such as in salt or ice, that heat has to be absorbed from the surrounding areas. Now, let's check our results. And now, I'm gonna grab my spoon. We're gonna see what it tastes like. And now, it's time for the num-num time. Let's eat it. That is so good. I want more. I made vanilla ice cream. You can't tell. Today we're gonna need some olive oil, an orange, some matches, a knife, a paper towel. And since we're using a knife in this experiment, you should have your parents supervise you. Okay, let's get started. First, we need to cut our orange in half. You might want to get your paper towels out because that's what you're going to put the pieces from the inside of the orange on. Now, what we're going to do after we've already cut our orange is we're going to take our knife, we're going to go around the edges, making sure do not break the sides because we're going to need those intact. And it's also very important to leave the stem intact as well. You can use a spoon to try and grab the meat out of here, but we're leaving that little stem in the middle. The next thing you do is you grab yourself a paper towel and you pat it dry on the inside. Getting pretty dry in there. There's our wick right there because we're gonna make this orange our candle. We're gonna fill our orange with some olive oil. Just make sure you don't go over the stem. All right, so here we go. We start filling. That's good, right there. So you see, it's right above where the olive oil is, and that is gonna act as our wick. All right, now let's light our candle. There we go, it lit. Citrusy. So, how does this work? Okay, if you remember the 3 tenets of fire, you need 3 things. You need fuel, heat, and oxygen. Now for this instance, the fuel for the candle is called limonene. Limonene is a flammable essential oil that is found in orange peels. Now in our candle, we're burning the orange pith, P-I-T-H, which are the little strings that run all the way through the orange. The pith contains small amounts of limonene, which makes the candle burn nice and slow. Be careful when using fire and never leave a candle unattended. And it's probably best to have adult supervision while you're using it. And now go out and make your own fruity candles.
For this experiment, we're going to be creating what we call a sugar rainbow. And what that involves is dissolving different amounts of sugar in the same amount of water. We're going to be comparing what they look like when we layer these different sugar solutions and exploring what their densities are going to be. The materials we're going to be using for today's experiment include the following. Definitely need some sugar. We are going to be using 4 glasses right here. You could also be using 4 beakers or 4, even bowls are fine too. We've got our water, since we need to mix and dissolve the sugar in the water. We've got our food coloring. This will help us identify the different sugar solutions we've created. We're going to be using this small graduated cylinder to show the layers of our sugar solutions. A spoon to mix the sugar in the water. This is going to allow more interactions. And then we've got some pipettes here that we're going to use to transfer our sugar solutions to our graduated cylinder. We're going to lay out our 4 cups. So we are going to be using the same amount of water for all 4 solutions. The only thing that's really going to be different is the amount of sugar that we put. Our first solution is going to contain 1 tablespoon of sugar. Our second solution is going to contain 2 tablespoons of sugar. And then lastly, for our 4th solution, we are going to have 4 tablespoons of sugar. Now that we've mixed and created our sugar solutions, notice how for our first container, it looks like most of the sugar has dissolved, but our last container over here does not have all of the sugar dissolved. So when this happens, what we'll just have to do is add a little bit more water. And again, we're gonna evenly do that. And then let's mix again. The reason why we mix or use a spoon to stir our mixture is we really want to allow these sugar molecules to interact with the water, because the water is what dissolves our sugar. Now, in order to be able to identify these 4 solutions, we are going to add food coloring. You will place the pipettes in each of these solutions, mix them up. Now that we've created our 4 colorful solutions, we are going to get our graduated cylinder right here, and we're basically going to put small amounts of each and observe for any layering. If something is the most concentrated, what that means is that you have more moles or more particles of your solute, which in this case, the solute is sugar. Let's check it out. You just need a few drops. Okay, we've got the green. Let's take a look at the red. We're gonna slowly add it on. This next solution has 2 tablespoons of sugar. So notice how you're seeing your green, red, and blue layer. And then lastly, let's check out our yellow. You see our 4 different colors, which means we have 4 different layers. And the reason why we are seeing the 4 different layers is because of the change in density. So your green solution that contains the most amount of sugar is going to be your densest substance, which is why it's on the very bottom of this cylinder. Meanwhile, your yellow solution will have the least concentration, and because it has the least concentration, it's going to have the lowest density, which is why it floats to the very top of our cylinder. We're going to take this a step further and observe what happens when we add a little bit of water to our column. And so notice how you actually won't see any of that water layering, because again, we know that sugar dissolves in water. So the sugar that is in the yellow layer wants to interact with more water. And that is the reason why we don't see a clear layering, because that water that I just added has actually mixed with our yellow sugar solution. For this experiment, we explored the different densities of different sugar solutions. We learned that your most dense solution is going to be the solution that contains the most sugar, and your least dense is going to be the one that contains the least amount of sugar.
Going back into time into the early 1900s when plastic objects were actually made out of milk. So the first thing we're gonna do is we're gonna take our pot, we're gonna put it onto the actual hot plate here, and I'm going to take my already pre-measured cup of milk and I'm going to pour it inside. I'm going to start pouring. Okay, now that we've got that in there, we're going to wait until it's slightly steamy. During the heating process, we're denaturing casein. This means that we are changing the shape of the protein, essentially opening it up and breaking the bonds that allow it to hold its shape. By opening the protein up or denaturing it, we are priming the molecules to create chains. Let's wait just a little bit and see if it starts to steam here in a minute. I'm gonna turn the hot plate up onto high heat, see what happens there. Now that it's steaming, we're gonna add 4 teaspoons of white vinegar. I've already pre-measured it, so that way I can just pour it in and I'll use my spoon to stir. So here we go. Here we go. I'm gonna start stirring. So as you can see as I'm stirring, that the milk proteins are separating and clumping up while I'm stirring. I'm gonna trade spoons because this is plastic. So we're gonna use this because it's metal. Now the white solids are called curds. So what we've done here by adding the acid is caused the denatured proteins to attach to themselves, and we've created polymers. Now for the fun part. We're gonna take our denatured proteins, or our curds, and we're gonna let the liquid fall. We're gonna start placing them onto the napkin. You're gonna wanna try and get as many curds as possible and place them in there. This is what you're ultimately gonna form your plastic out of. We're gonna dry it off with a paper towel, trying to remove as much moisture as possible. And this will essentially be our casein dough. Now we can start molding and shaping our polymer dough. And once you've made your shape, you're gonna wanna let it dry for 48 hours. Luckily, I've already prepared one, and I created a duck, a little chicklet. It's pretty cool, huh? Once your dough has dried for 48 hours, you have officially made milk plastic. Isn't that cool? Now I need you to remember, while milk plastic is heat resistant, it isn't moisture resistant. So please keep it out of water. Now, go out and make as many milk plastic figures as you like, and catch us next time on Expulsion Science.